All right, so you chose to have the guided notes, which just means you're going to hear my voice in the background. Some people prefer this. If you prefer that, awesome, stick around. If you don't, go to the regular notes and you don't have to listen to my voice, and that's okay. I will interject a few things here and there, so you might find that helpful, and maybe you decide that it's not. So either way, you're going to get the same information. So what we're dealing with in this unit is all about matter. And what we need to know is that matter is anything that has mass and takes up space, so mass and volume. And now this umbrella of matter is kind of categorized into 4 different groups. So let's take a look at that. So you should have your note sheet by now. If you don't, make sure you run in the back and go get it. Also, make sure that you know that you can pause this at any time. Feel free to ask questions throughout, anything that you need. So if we look at matter, the big thing is, can it be physically separated or not? So there are mixtures and then there are pure substances. And then from there, we can break things down additionally. So let's take a look at the side that is, yes, it can be physically separated. So what does that mean? That means it has a physical separation method, that we are not doing anything to the atoms themselves. We are just simply separating the mixture apart. So into smaller, more pure substances, but again, not that pure all around. So if we're looking at the mixtures, we have 2 types. We have homogeneous or homogeneous, and these are consistent throughout, meaning they look the same. We also call this a solution. So if we're talking about anything that has something dissolved in something else, that is a solution. It looks consistent throughout. You can't tell a difference. It just kind of looks the same. So that's why we call it homogeneous or homogeneous. So homo means same. So we can use that to help us kind of understand the idea here. So if we take a look at examples, and my suggestion would be write 1 or 2 of these down in your notes so that you have them. You can take a look and just see all of the ones that you see here are just a consistent group. Okay, everything looks the same, whether it's a solution like Kool-Aid or milk, which is actually homogenized, because normal milk would actually separate, but we use a special fancy procedure to make sure it doesn't separate. But also you have groups of things like all red M&Ms or pencils or a boy band. They're all boys. So everything that you can see here, this is the example from your breakout, is showing that they're all consistent. So now if we take a look a little bit closer, if we zoom in, let's say to salt water, which is a solution, and all the salt is dissolved, this is what you'll see. You'll see a consistent dispersal of the particles, meaning it looks the same. And this is the reason why it looks the same, is because of that even dispersal. So this would be an example of a particle drawing. Again, probably helpful to maybe sketch this off to the side of your notes to help you later on with the practice. All right, so we have homogeneous, looks the same. Another type of mixture is heterogeneous. This has distinct differences, meaning it doesn't look the same. You can definitely tell a difference. So if we go back to the breakout examples, here we go. So we have Skittles, definitely look different. We have dirty water. You can see different particles in that, different colored markers. Oil and water doesn't mix. A group of kids, different races, different genders, all of those things. So each one of these, you can definitely see a difference. It's a mixture. It's not pure. They're not chemically bound together, but you definitely see a difference there. So if we now zoom in to, let's say, something that would be like maybe dirty water or sand and water. So this would be the sand down here where it has not mixed in, it can't dissolve. And then this is your water up here, kind of sitting on top. Again, making sure, showing you that it's not dissolved. That's why we see it's not evenly dispersed, and that's why we see the differences in there. All right, so those are our mixtures. Again, mixtures can be physically separated using physical separation methods, magnetism, chromatography, filtering, all of that kind of stuff, which we'll get into later. Now, chemical separation would be on the other side, meaning it cannot be physically separated. If that is the case, it's got to be a pure substance. So pure substances, there are 2 different types. The first type is an element. That is the most basic pure substance that we have. It's made up of only one type of atom. And how to find examples of this, it's pretty easy. If you are given an example and you're trying to figure out if it's an element, if it is on the periodic table, if it's listed on here, it's an element. If it's not listed on here, it is not an element. And that means, therefore, it is either going to be a compound or one of the mixtures. So easy one to spot. Now, if we look at the particle example or examples, you'll notice a couple of different things. One, elements can be by themselves, like this drawing, okay, where you just have individual elements of something, all the same type. Or they could be diatomic, meaning that there's two of them bonded together. They're the same element, but they're bonded. Okay, that's still considered an element. So here are examples of some diatomics. So hydrogen gas, H2, O2 is oxygen. So all of these things, even though that they're bonded with something else, because they're bonded together, they're still considered an element. All right, now let's take a look at your next pure substance. And this is a compound. So this is a little bit less pure in the fact that you don't just have one type of atom, you have more than one type of atom, and those are bounded together. So if we look here at some examples, here we go. So we have water, H2O, so two hydrogens bonded with one oxygen, or you have nitrogen dioxide, two oxygens bonded with one nitrogen. Okay, so all of these, you can see there's one more, or there's more than one element bonded together. And it doesn't have to be just two, it can be more than two different types of elements. So, I mean, that's a particle drawing in itself, but here's another one, again, showing that there are more than two or more elements bounded together. And chemically, you would need chemical means to separate that, meaning we would have to break that bond. All right, so if we pan back out here, again, just to kind of recap, we have matter, and it can be in four different categories. And the way that we can do it is if it can be physically separated, which means it makes it a mixture, and it can be chemically separated or not physically separated, which makes it a pure substance. One more thing to kind of make note here, if we're talking about mixtures, if I get a mixture from someone, for example, if I get Kool-Aid from someone, which is a homogeneous mixture, and I get Kool-Aid from someone else, they're probably not going to be the same. Maybe different flavors, different amounts of sugar, that kind of thing. Same thing with a heterogeneous mixture like trail mix. If I buy trail mix from Kroger's, it's definitely different from the trail mix from Walmart. So that's how we know things are mixtures as well, because you're going to have variation. However, if you go on the other side to pure, if I have an element, if I buy gold and it's pure gold, it's only gold. You do not have any variation there. Same thing, if I want to buy carbon dioxide for whatever reason, and I have to obtain it, there's only one type of carbon dioxide. So again, when we're kind of trying to figure out what the difference is here, one, can it be physically separated using our separation techniques, which we'll get into, or two, is there any variation? If there's variation, then yes, it's a mixture. If there's no variation, then it's pure substance. So now you're going to use this information, and you will then go into the activities to help you, and then you can practice after that. Let me know if you have any questions.